basically, this is our problem that we were asked, and this is one of the hardest problems that you'll get because there's more conversions that you have to do later. So basically what I did here is wrote out all of the equations that you'll use using the ALEKS. So if it asks for volume, then you would use this equation and T, P, and N. So basically, we'll just start the problem. The nitrogen monoxide gas is collected at negative 15 degrees Celsius in an evacuated flask with a measured volume of 30 liters. When all the gas has been collected, the pressure in the flask is measured to be 0.38 atm. And you're looking for the mass and the mole. So, I should probably write this. V is volume, right? T equals temperature, P equals pressure, N is the moles, and R is these two. So in every equation, you have to use an R, and you find your R, whether P is PA, or V is M to the third, or P is considered ATM and L. So as you can see here in the equation, it says 30 liters and 0.38 ATM. So this will be your R. Make sense?
No.
Okay.
Why is that one your R, not the top one?
Because this one, when your pressure is ATM,
Oh, I got you.
ATM, the pressure, right? Then you'll use this one. And let's say the pressure was PA in pascals, then you'd use that number. Now, does that make sense?
Yeah.
Okay. So now we can actually start doing our equation. So we're looking for the mass in the mole, which is this, N. Make sense? Yeah. Okay. So N equals what we're looking for. So to find N, we need pressure and volume at the top. So we'll look at our equation and look for our pressure, and it says the pressure in the flask is measured to be 0.38 atm. So that's going to be our pressure. So we'll write 0.38 atm. Does that make sense?
Yes, thank you, Jim.
Okay, and then, oh, let me know if I'm going too fast.
You're good.
Okay, and then, so that's where we got the pressure. So now for volume, we have to look for the volume. It says, in an evacuated flask with a measured volume of 30 liters. So we'll put it here, 30 liters. Does that make sense where I got that from?
Yes.
Okay. Now, so now we already have our N, or that's what we're looking for. We already have our pressure and our volume. Now we have to look for our R and our T. So our R is gonna have to be one of these two. So I would write that down in your journal or something.
What?
Write down
the two numbers.
Because you're gonna, those are the only two options that you have to put in for your R. So, should I keep going?
Yes.
Okay, so since our pressure is in ATM form in atmosphere, and our volume is in liters, we're gonna use this number. But if it said the pressure in the flask is measured to be 0.38 pascals, and the volume is 30 m to the third, then we would use that number. Make sense? So since it's in this form, we're gonna use this number as an R. So we'll write 0.08 2574, and then that's our R. Okay. And now we have all those three, and now we have temperature, which is what we're missing. And usually, whenever you do temperature, you usually don't want to have it in Celsius. You want to have it in Kelvin. So if you look up on the Chromebook, Celsius to Kelvin, you just put, so we're looking for negative 15. So negative 15 Celsius is equal to 258.15 Kelvin. Make sense? So now we just add that into our equation. So we'll put 258.2 Kelvin, because we could just round it. Or you could do 1.5, it doesn't matter. But I do that because it's easier. So now we have our whole equation. So we have our P, this is our P, this is our V, our R, and our T. So does that make sense
Yes.
so far?
Yes.
One question.
Yeah.
Can you teach the class for the rest of the year? Maybe take over Mr. Heath's job. Please.
Yikes.
I don't
Okay,
care.
so that's gonna put it in.
Anyways, so now you plug it into the calculator, and I wouldn't do like plug it all into the calculator at once, because if you miss some number, you're gonna get it wrong. So what I usually do is I put parentheses 0.38 parentheses 30 parentheses. So this equals 11.4 over, and then we multiply that, 0.0820574 and 258.2, and then you get over 21.187. So then once you have that, then you can just divide those, and you get 0.54 moles. And we're only using 2 sig figs, I think.
Yeah.
If not, you could just like maybe put 3 or whatever. But the sig fig thing's kind of weird. So we have 0.54 moles, right? So that's what we put in here. 0.54 Kg.
Mhm.
Okay. And then now we're looking for mass in grams, which is it's the same thing, except for now we have to go into 1 mole conversion. So 0.54 moles times, and then this is when we use stoichiometry. Okay, for these, this is the only one. If you're looking for n, that's probably the only one you're actually gonna have to keep going. Because the rest, once you have that and you solve it, then that's when you're gonna get that. And you're done. But this one is a little bit longer. So then, from going to moles, we're going from moles to grams, right? Mole to mass. So we have to multiply this by the molar mass over 1 mole. So now you're probably asking what are we looking for the molar mass? It says dinitrogen monoxide. So that's the molar mass that we're looking for. I'm just gonna look it up, guys. Okay, so the molar mass is 44.013. Do y'all know how to find the molar mass?
Yes.
Okay, so no.
Yes.
Can you look it up?
Well, one person doesn't know, so I'm just gonna like summarize it. So to find the molar mass, let's say there's dinitrogen. Nitrogen by itself is
14.086.
okay. So nitrogen is N2, right? But it says dinitrogen. Yeah. Monoxide.
Wow.
Huh?
Sorry, I'm sorry.
Oh, sorry. Monoxide is CO. So now we have to look for that. So basically all you do is look at C, find. Okay, so if you look at O, you get 15.994. So you put 15.994 plus the atomic mass of that plus the atomic mass of that. And you multiply the time by 2, and then add it all together. Make sense?
Mm-hmm.
Okay, so then you plug that into your calculator. And you get .68 grams. It should be grams. So that cancels out. Sure. Yeah?
Mm-hmm.
So your answer is 23. Actually, 24. Because we rounded it. Yeah? Does that make sense?
Yes. A lot more than what Mr. Heath did. Yeah.
I could do another one.